In problem 2.39, we're asked to find a single equivalent resistor REQ for each set of terminals. There's a part A where you're given this circuit here, a 6 ohm resistor, 3 ohm resistor, another 6 ohm, and another 3 ohm. And then part B has this configuration here with a 2 kilo ohm, 3 kilo ohm, 6 kilo ohm, and another 6 kilo ohm down here. Let's start with part A. So if we look here, there's nothing that seemingly is in series, because remember, we have the definition of two resistors in series have to mutually and exclusively share a particular node. So if you look at this particular node right here, that's shared with 3 resistors. You look at this node right here, this and this node actually end up being the same because the only thing that's across them is a wire. So topologically, those are actually the same. Then you look down here, and these are not in series. They would be if we didn't have this branch up here. But now let's look and see if there's anything in parallel. And remember, our definition of resistors being in parallel is that they have to share the same 2 nodes. So if we look here, we see that this 3 ohm resistor shares a node with this 3 ohm resistor, but then this other side is not connected to 3 ohm, so those two are not in parallel. If we look over here, we see this resistor, the 3 ohm across the middle and the 6 ohm at the top, share this node right here, and then if we were to stretch this around, we notice this node and this node being equivalent. This 6 ohm resistor and this 3 ohm resistor are in fact in parallel. And so we can find a parallel equivalent of 6 ohms and 3 ohms by saying 1 over REQ prime. I'm going to notate that as REQ prime just because it's not the same as my overall REQ. This is just an intermediate equivalent resistance that I'm computing so that I can simplify my circuit. And so I have this reciprocal relationship. 1 over REQ prime is equal to 1 over 6 ohm plus 1 over 3 ohm. I find a common denominator to be 6 ohms here. And so I ultimately use that to say, okay, 1 over 6 ohm plus 2 over 6 ohm gives me 3 over 6 ohms. And if I were to flip that back around to get REQ prime, I would find that the equivalent resistance for a 6 ohm resistor in parallel with 3 ohms is in fact 2 ohms. And so now I'm going to simplify the circuit and replace these two parallel resistors with a single 2 ohm resistor. Effectively, you can think about stretching this up, running it into the 6 ohm, and those two paths being one unified path of this 2 ohms. That is still connected right here to the 6 ohm that we had before. And now we're just going to stretch the branch that previously stopped right here. Even though this is equivalent, one big node, now the 3 ohm is connected up there. Now, as drawn, we can see some fairly easy series and parallel relationships. The 2 ohm and the 6 ohm are clearly in series. That's the easiest one to combine, so let's just go ahead and add 2 to 6 and get 8 ohms. So we'll notate that as REQ double prime is this 8 ohm, and now we just get an 8 ohm in parallel with a 3 ohm resistor. We can do this reciprocal relationship again. So we get 1 over 8 ohm plus 1 over 3 ohm is equal to 1 over REQ. Finding a common denominator of 24 ohms, we get 3 over 24 plus 8 over 24 gives us 11 over 24. Taking the reciprocal there, REQ is equal to 24 elevenths ohms. Now let's move on over here to part B. And what we'll see here, let's look and see if we have things that are connected in series. Well, over here we have 3 different branches all connecting resistors, so there's nothing in series there. These would be in series if we didn't have this extra wire coming out right here. And so what can we see? The 6 kilo ohm resistors are actually in parallel with one another. Why? This 6 kilo ohm and this 6 kilo ohm clearly share this one right here. But if you look at the other node, The only thing that is connecting over here is just a wire. So this node here is shared by both ends of both of the opposite ends of the 6 kilo ohm that are not right here. So this 6K and this 6K are in parallel. And when we do the reciprocal relationship, we'll find out that the equivalent of a 6K and in parallel with another 6K is in fact 3 kilo ohms. One of the things that you will find as a truth whenever you are solving for two resistors in parallel that have the same resistance, the equivalent is actually just going to be exactly half of the resistance of the individual ones, which kind of makes sense. If you have two paths that are equally resistive compared to just having a single path, you're going to have half as much resistance because you could split the current half on one side, half on the other side. So now that we've combined this into a single 6 kilo ohm, two 6 kilo ohm resistors into a single 3 kilo ohm, now we have a circuit that looks like this. Now we can clearly see this 3 kilo ohm is in series with the 3 kilo ohm up here. And so we can combine 3 plus 3 into a single 6 kilo ohm. And now we have a 6 kilo ohm in parallel with a 2 kilo ohm. We can use this reciprocal relationship and determine that that equivalent is a 1.5 kilo ohms. And that is the last resistance that we have left between this terminal and that terminal. So the answer here to part B is 1.5 kilo ohms.